Impulse. We define momentum as mass times velocity. We define impulse as the change in momentum. Thus, we can logically deduce that impulse equals mass times change in velocity, or m times v minus u equals the impulse. The principle of conservation of momentum said MAUA plus MBUB equals MAVA plus MVB. Remember this from the first video. So we can modify some things in these equations. We have the MAs on the left-hand side of the equation, and we have the MBs on the right-hand side. We factorize. Now, remember, impulse equals m times open bracket v minus u close bracket. So this actually resembles the equation directly above the impulse equation, and also on the left it also closely resembles that, except that in that case we have to multiply the impulse formula by -1. So we get impulse equals ma open bracket ua minus va close bracket, also mb open bracket vb minus ub close bracket. We saw this example in an earlier video. We worked out that VB equaled 6. Now we can work out the impulse. And we have two ways of working this out. The first way, we can do MA times UA minus VA. Let's try to substitute the values into this equation. We get impulse equals 2, open bracket, V minus 2, close bracket. Impulse equals 4 Newton seconds. So the unit we are going to use for the impulse equals Newton seconds. We can also work out the impulse with the other equation, mb times vb minus ub. Let's substitute the values in. Impulse equals 1 times 6 minus 2. Impulse equals 4, giving us the exact same answer. Let's take a look at some exercises. Sometimes I give you the values with a little a by it, and sometimes I give you the values with a little b by it. In either case, we should always work out the impulse on all 5 of these equations. Please pause the video and try them.